Okay, so one of the first concepts we're going to do in chemistry to calculate, or rather, one of the first calculations we're going to do is density, how to calculate density. And there are two ways that you can calculate density. One of them is with a formula, and the other one is just by looking at the units. I will admit to you that I've been doing density for so long that I really don't see the difference between these two methods anymore. And so in class, when I'm doing this at the board, or when I'm talking about it, I'm just going to blend the two methods together because they're really the same thing. I'm not sure that I'm going to be able to convince you that they're the same thing, but that's sort of the goal, is for you to see how equivalent these two methods are. So again, the one method is just to look at density as a formula, and that is the density is equal to a mass divided by a volume. Maybe at the beginning of this you should simply memorize this formula, and this is like a rate, distance, time problem that we did in high school. Rate is equal to distance per time, and we did this when we were calculating, a train leaves Chicago and another train at the same time leaves New York, and they start going toward each other at certain distances and so on. Remember those problems in high school? Well, it's really the same thing. So, or I should say the same concept, and that is that a distance is equal, density is equal to this dimension divided by that dimension. Okay, so that's the one thing that's the one way to calculate it, and maybe that's the best way to start. The other way, I think, that's my density is equal to mass per volume. Okay, the other way is to think about it in terms of its units. So the units of density are grams per cubic centimeter, right? And you know that by the way the question's worded. So the density of a particular metal, you'll get something like this. The density of aluminum is equal to 3.7 grams per cubic centimeter. And if you can think in terms of dimensions, you can see that's supposed to be a G. Grams per cubic centimeter. And you can see, hey, there it is. It's mass divided by volume, right? So density is equal to mass divided by volume. And basically what you've done when you recognize just the units there, you've essentially made up your own formula. And that's, I think, by far the best way to calculate densities. So still, I'm going to start out with the simpler way, and that is the simpler but not as reliable method of simply memorizing a formula. Okay? So the way I'm recommending, though, is to look at the units or the dimensions, and that is the density is equal to mass, right, there it is, divided by volume. Okay? And so I'm going to be doing a ton of problems like that this entire semester. It's really a great way to solve problems. Okay, so let's look at the simplest version of that sheet of paper. The simplest version of any density problem that you could get. You should expect to have a problem like this on your first exam. If it's not there, then we'll have the next simplest, but the very simplest one, you've got to be able to do a problem like that, okay? So suppose you're given a mass and a volume. If you're given a mass and a volume, what are you going to be asked to calculate? Please pause the video right here, and if you don't know, pause the video and think about that and make a guess. Okay? I'm going to suppose that you paused it. If you're given a mass and a volume, you're going to be asked to calculate a density. Okay? Let's consider this the next scenario, which is still one of the simplest versions of it. If you're given a mass and a density, what are you going to be asked to calculate? Sure, a volume. Okay? And then number 3, if you're given a volume and a density, what are you going to be asked to calculate? Exactly, a mass. Okay. All right. So let's do an example. Suppose that we've got the density of a block of aluminum is 3.7 grams per cubic centimeter, and suppose the volume is equal to 4.4 cubic centimeters. Okay. So we have a D and we have a V, and we need the M. That's what we're being asked to calculate. So what I'm going to do every time is I'm going to do it with the variables first. D is equal to M per V, right? And I'm looking for my mass. So one temptation for students when they're new at this is to put the numbers in, because numbers are concrete and you're more comfortable with the concrete. I'm going to suggest that you stick with the abstract because you'll find that all the problems end up looking the same later. They all look the same if you get used to working with variables. So that's exactly what I'm going to do here. I'm looking for mass, so I'm going to say mass is equal to V times D. Okay? And so it's 4.4 cubic centimeters. That's my volume. My density is 3.7 grams per cubic centimeter. My cubic centimeters cross off, which is a big deal to me because I want to always make sure that I'm doing things right, and that's a great safeguard. I'm going to calculate this. 4.4 times 3.7 is equal to 16.28. Is equal to 16.28. Okay, that's the mass. Grams, because I've got grams left. 16.28 grams, right? Now, if this is multiple choice, one of your choices will probably be 16.28. Another choice will probably be 16.3. 16.3, which is correct. Well, it equals 16.28, but you can't report it to that because both of these only had how many sig figs? 2. 2 sig figs and 2 sig figs. 2 sig figs, 2 sig figs. And since this is a multiplication problem, your answer must only have 2 sig figs. Okay? Oops, 16.3. That's not even correct. Another possibility is 16. Well, that would be a hard problem, wouldn't it? Because it's going to have 2 sig figs. So what I would say, if I'm writing this down, this would really bother me writing down equals 16 because you know you've got these digits here, right? I would say, if it's an open-ended question, you're allowed to calculate like you like. You can say 16.28, which is approximately 16 grams because of sig figs. Okay? If this is a multiple choice question, this is the correct answer right there. Okay, another word about calculating density problems. That's just the simplest possible version of it. Let me say this: strategy for studying for exams. If every concept you get this semester, every concept you get in any class really, you should be able to do the simplest version of the problem. You must be able to do the simplest version. If you can't do the simplest, you're gonna fail the exam, plain and simple. Because we can't get easier than the simplest. Okay, so be able to do that well, easily. On a hard day. Make sense? Then after you've done that, so you need to go through all your concepts and make sure you can do the simplest version of every concept. But after you do that, then you need to go through and say what's the next simplest, or something that's simply not the simplest, right? You've got to be able to do that too. That is, if you must have a perfect score, well, you've got to be able to do all kinds of hard things, right? But first of all, before you worry about a perfect score, you should be able to do the simplest problems. All right, so let's talk about what's the not simplest problem. I'm not going to calculate one of these, but I want to give you two scenarios. Here's one that's not simplest, okay? The mass of a cylinder is 10.8 grams. So I've given you mass. It has a diameter. Whoa, uh-oh. A diameter of 1.23 centimeters and a length of 5 centimeters. Okay, so first of all, what am I asking you to calculate? Well, ultimately, these are going to come together to calculate what? You know what? I'm not going to tell you the answer for that. I want you to figure that out and ask me in class, okay? What are you being asked to calculate here? All right, and then finally, what's the question going to be in the end? What is its blank? Okay, so I'm going to ask those two questions here in class. What are these going to come together to form? And then finally, what is its blank? Okay? That's a tough question. Well, no, it's not tough. I wouldn't say that. I would say it's a little abstract, and I want you to think about that. It's going to help you if you do it. Okay? And number two, here's another one that's not the simplest. The mass of a cylinder is 10.8 grams. It has a diameter of 1.23 inches. Okay? What's the next question? Or what's the next step for you to do? Okay? What do you have to do? Alright, so that's 3 questions I think I'm going to ask you in class. Somebody remind me, in case I forget. Alright, so hopefully that's helpful. That's a pretty thorough introduction to density. Let me remind you that density is equal to mass per volume. And if I give you a mass and I give you a volume, it should be routine to calculate the density. And if I give you the density and the mass, it should be very simple to calculate the volume. We've also considered a couple scenarios in which the question would be not so simple. Okay, best wishes. Let me know what I can do to help you.